Today we'll be going over LVM. This is IBM AIX 80-20 training, solving 80% of the problems with 20% of the knowledge. So we'll go over today LVM. We'll start off with some basic storage concepts, relationship between the physical volume, logical volumes, and the volume groups. Um, what are physical partition and so forth, and in the red book, we'll go through a little bit of the file system chapter. That chapter pretty much, contain bulk of the information uh, that didn't make sense to reproduce. So we'll just go through that certification guide on the file system chapter and see what different type of task a typical admin will get when doing in relationship with file systems. This is something I put together to uh, to help uh, admins to better understand volume group, storage management, and AIX. Okay, so the first part in the light yellow, you have two pair of disks. Uh, So when you're when you're considering them outside of a volume group, they're just considered to be regular disk. Um, and when you add them into a volume group, and you're adding these disks into a volume group, now they're considered to be physical volume, meaning something that's physical. That's something that you can physically touch. It's a hard drive. I mean, it's all it is. It's a disk. It's a hard drive. So it's referred when you add it to a volume group, it's referred to a hard drive. And so the first when you first create a volume group, there's certain configurations that you can pick. The minimum amount of disk that you need to have for a volume group is, of course, a one, and we'll go over some of the limitations a little bit later on the volume groups, LVM, and so forth. When you when you add a disk to a volume group, one of the critical things is that you cannot change is the partition size. The partition size is how big you can say as blocks, that it will divide the hard drives into blocks. So how big the blocks should be. When we were recently, setting up several systems, the SAN architecture for that group gave us a recommendation of 128 megabytes of for the partition size. So that means that each one of these blocks that in the small boxes would be 128 megabytes. So so if you have a 10 gig hard drive and a partition size is 64, so you have 64 times uh, 64 megabits times 1024, well, gives you how many partitions you would have. Okay, or actually you would divide. You would divide. That would tell you how many partitions you had, not multiply. And if the partition size um, are bigger, that means you will have less number of partitions per that disk. Okay, so like on our server for root VG. Okay, so let's see, we're running. I believe we're running 5.3 on this server. Yep, 5.3 TL7. Uh, and let's see what's the default um, size of the root VG file partition size. Let's see what it is. So we're doing the lsvg command, and the parameter that we're giving it is root vg, is the vg name. Hitting enter. Okay. So here's some information here in volume group name, volume group identifier. And this is what we're interested in right over here. Okay. Now, the partition size is 16 megabytes. That's how small the partition size are for root VG. The total number of partitions, depending on how big the partition size, is 542 partitions. And it gives you a rough estimate of how many megabytes are available. So roughly 8.6, 8.6 gigs. And how many are currently available? How many are being used? Okay, this is how we can check on the partition size, on the total number of partitions, and what's the available size, and what's available for that in that VG. Okay, back to the concept. Now, so you add the disk to the volume group. Now they're called physical volumes. Every physical volume in that VG will be partitioned into physical partitions, which is also referred to as PP. Now, then these physical partitions are pointed by another partition referring to as logical partitions. Okay. Now it seems like a little redundant, but these logical partitions are there for a reason. These logical partition and these logical volumes are virtual, and this what gives LVM and IBM that robust and flexibility to be able to um, expand the file system without recreating it, reduce and shrink the file system without recreating it. If you remember back in the days, every time we needed to add the storage to a file system, we would have to back up that whole file system, make sure we had a full backup. We destroy that file system and then recreate that file system and then restore it from the backups. Okay, with IBM's LVM storage management, you don't have to do that. Okay, you can expand, shrink anytime you want without any issues in real time. Another benefit is the mirroring capability. Okay, if this was mirrored, each logical partition would point to two separate physical partitions. If the disk is mirrored one to one, if you have a partition, it would be pointing to um, two separate physical disks. So when you write to the logical partition, you are actually writing to two physical locations on two separate disks. Okay, logical volumes are made up of logical partitions. Okay, so you can think of logical volumes, physical volumes, as virtual disk, virtual physical volumes, and then the file systems are mounted to that logical volume. Okay, so when we look at a command df-g, this is the logical volume. Okay, and this is the file system which is mounted to the logical volume, and these are the standard file systems you will see on every AIX server, and this is pretty much the standard file system size you will see on virtually every AIX system. And if you built it from scratch, this is the size you will see. And if you and typically whenever you would admins would have post build tasks where they would go through and adjust and increase the size accordingly. So I hope this is fairly clear that the logical volumes are made up of logical partitions. Okay, so logical volumes, you can think of them as virtual disk, and each logical partition uh, are pointing to physical partition, either one or many, depending on the configuration. So in logical partitions, again, are just um, blocks of physical volume that the disk is divided and grouped up into physical blocks, referred to as physical partition. And a file system points to a logical volume. Okay? So over here is just some very basic concept. I'll read through these sections really quickly. The fundamental concepts used by LVM are the physical volume, logical groups, volume groups, physical partition, logical volume, logical partition file systems, and each individual disk drive is named a physical volume and has a name such as HDisk 0, HDisk 1. Okay, that is the standard naming convention for the disk in AIX, using the generic code without any external or third vendor software. One or more physical volume can make up a volume group, basically meaning you need at least a disk to create a volume group. A physical volume group can belong to only one VG. Okay, so again, in English, that means that one disk cannot belong to more than one VG. Okay, it has to be in only one group, which makes sense. Okay, if you look at the picture, a disk cannot go into two separate boxes or volume groups. It can only go into one place where it's partitioned and configured accordingly. You cannot assign a fraction of a physical volume to a VG. A physical volume is assigned entirely to the VG. Okay, I should be actually be more precise. In AIX, you have the whole disk goes to a VG. You cannot partition the disk and give it to a piece here, piece there, do this, whatever you want. And actually, in Red Hat, which they gave the code to IBM, shared the code or sell the code, I don't know, with the Red Hat, with their version of LVM. You can use fdisk to actually partition the disk and do the opposite of actually what this bullet point is saying. That you can actually in Red Hat you can do this, but in AIX you cannot do this. Storage spaces from the physical volume is divided into physical partition, as we mentioned earlier. The size of the physical partition is identical on all the disks belonging to the same volume group, meaning that all the disk all the disk in that volume group will have the same PP size. Okay, different VGs can have different PP size, but every disk, regardless of the size, in one VG you can have a disk that is 10 gigs, that is 32 gigs, that's 100 gigs. It doesn't matter what size it is. Okay, but each one of those will have the same PP size, which is configured on the VG. Within within each volume group, one or more logical volumes can be defined. Data stored on the logical volume appears to be continuous from the user's point of view, but it can be spread on different physical volumes on the same volume group. Okay, kind of something we mentioned with mirroring. Okay, LVM is very powerful tool, and it also offers the ability to do striping. But with striping, you cannot uh, add additional storage to it. There is some issues with striping, so if you were to do striping with AIX, you need to be aware and you need to do proper planning that once you decide to do striping, that's it. I mean, you had to recreate that file system, like I mentioned before, because when it does a striping, it's writing the disk and striping across, for instance, 4 disks. So it does the calculation and everything, and does that currently. Okay, we'll stop over here as being as part one, and then we'll continue with the remaining of the lecture in part two. Thanks. Bye bye.